All right, everybody, it's time to start. So we're going to jump in. You all are the real heroes of KubeCon, knowing the hour that we're at, and you could have chosen the pub with your friends or gone to SLC 6 hours early to sit in the lounge or whatever, but you're here, so that's awesome. And we're going to hopefully reward you for your persistence by not having a boring presentation. We usually do that for this talk, and thank you for those of you that come year after year to hear what's up with Containerd, but we thought we'd shake it up a little bit and just bring up a bunch of maintainers and answer some questions that, not from you, sorry. If we have time, we will toward the end, but we've kind of pre-selected some questions just to kind of use that as the vehicle to catch you up on what's been going on in Containerd. We were going to do Family Feud, but Tim stole that for the keynote, so we'll just stick with the panel today. So, yeah, this is going to be a conversation. We're going to, if you missed Sam's talk a few hours ago, he dove pretty deep into 2.0 and upgrades, so that'll all be on YouTube in a week or two. I don't know if we're going to get that deep on Containerd 2 migration, but all that information is available in his talk. And so hopefully this will be fun. So quick intros. I'm Phil, a maintainer of Containerd who works for AWS and also dabbles in the OCI and some other pieces of our container runtime ecosystem. And then maybe we'll just walk from that end this way.
Yeah, hi everybody. Mike Brown. I've been with IBM for a long time, did operating systems, JVMs, ran up the stack for decades, right? Did DOS even, fun. I'm currently maintainer of the OCI specifications for distribution, and help out with artifacts across the image spec. Also, I've been doing as much as I can with Signode, trying to help out the kubelet guys review some of their KEPs, if not do some of the implementations. I'm a maintainer of Containerd. Sure.
Hi everyone, I'm Sam. I'm a software engineer at Google. I'm also a Containerd maintainer. I serve as the chair for the OCI Technical Oversight Board. And then I've also been getting more and more involved with Signode to help out with things there as well.
Hi everyone, my name is Kirtana. I'm a software engineer at Microsoft, and I've been working in Containerd, Kubernetes, and AKS with a focus on Windows. And also been a container maintainer for over or close to a year now.
Hi, I'm Akihiro Suda from NTT Corporation in Japan. I'm a maintainer of Containerd and runs the OCI runtime spec and Mobi, build it, and other projects. And I'm also leading a DIMA project, which is also a CNCF project.
And like 10 other things that Akihiro's done that he didn't list. So if you're using containers in any form or fashion, you're definitely using some of Akihiro's work. So it's awesome to have this group of maintainers. A lot of us have been in this ecosystem for a while, back to the early Docker engine days, been contributing in various ways from a lot of different roles we've had. So first question that might be on your mind, maybe not if you've been around the community for a while, but some people are like, hey, why Containerd? Why does it exist? So I'll take a stab at it, and if any of you want to throw something in. So you've probably heard people reference the dark days of the container runtime wars, or some talk about some friction and difficulty in the 2015, 2016 era. And out of that, ignoring all the things that were going on at the time, one of the very clear messages was Kubernetes would love a stable core container runtime that doesn't maybe have its own features or enterprise product related to it. And so Containerd came out of the Docker Engine project. If you're aware of that same era, the OCI was formed. Parts of the engine were also donated to become runwasi and libcontainer in the OCI. And so really in that 12 to 18 month period, in a sense, Docker was decomposed into some pieces that went to OCI, Containerd ended up being announced as a CNCF project at the KubeCon in Berlin, March 2017. And so essentially it was to play this role of, being this core stable component that Docker could rely on, Kubernetes could rely on, and obviously 8 years down the road, we've continued to try and, stay with that very straightforward scope and focus, while also adding features and making it modular and making it pluggable so that people can do, a lot of the interesting things we've seen people do with Containerd over the last 8 years, from, the WASM, the runwasi shim, to have our shim layer that's pluggable, that can do everything from kata to gvisor to WASM, and of course, default to runc. So, I think that's, maybe someday someone will write a book about how all those things came to be and all the excitement of that era. But essentially, that's the core of how the project came to be and kind of what has been our mission for 8 years. So anything else to add?
Well, yeah, since we have Tim here, I can a little shout out to him for the Cry API and for the Google team to put together Lantau Lu to work with us to put together the Cry Containerd plugin on the initial proof out to be able to run Kubernetes with Containerd. That was fun.
Yep.
And we're still working together on that. So yeah.
Absolutely. Cool. So yeah, okay, that's great. You created this project 2016, came to the CNCF 2017. What value does it bring to the overall cloud native ecosystem? Who wants to jump in on that? Anybody? Come on.
I think you want to go first, Phil.
Somebody. What'd you say?
Okay, or Mike.
I could jump in. Yeah, Containerd is being used by almost everybody in the ecosystem. Okay, it doesn't matter if you're doing Ray AI, right, or if you want to just run a Docker container. Containerd is right there. We've just become a very broad, popular tool for engaging with creating a container locally. Either be it through the CryCTL API if you need Cry, or a local up cluster and you're doing some development testing. It just seems to be very ubiquitous at this point in time. I can't name all of them, but
yeah. I think one of the core things that comes to mind for me is we've approached Containerd, obviously created the core. The very straightforward thing that everyone wants is that here's a piece of software that knows how to create the OCI config, pull and push images to a registry, turn them into a running process on a system. That obviously that's the core of container runtimes. What I think we've done well around that has created value is making sure there's extension points for those who want to do something unique or something special that's allowed there to be a lot of kind of growth outside of what the Containerd team does. Everything from Akihiro's projects with nerdctl. These are all projects with their own sets of maintainers and contributors. Like runwasi, it's its own sub-project that has its own set of maintainers and contributors. And so that ecosystem, I think, that has been the value that Containerd's brought beyond just, okay, here's something that runs, takes these OCI images and turns them into running processes on a host.
I would add to this, like the extension points that we've built in Containerd, I think they've been really useful to, like, you can use them with Kubernetes, you can use them with other sort of front ends for running containers, but we have things where you can swap out the runtime, like Phil was talking about with runwasi, or there's a couple other kinds of backends for running containers, like you can run Windows containers, you can run FreeBSD jails, things like that. There's also an ecosystem of what we call snapshotters, but are mechanisms for storing the container layer contents, and a growing set of remote snapshotters that can do things like image streaming or lazy loading, which is pretty interesting use cases, and those work well with the rest of the ecosystem on top of them. One of the things that I was highlighting in the talk earlier today was NRI, the Node Resource Interface, is a newer extension point that we've turned on by default in 2.0, but that's another way to plug in and customize the behavior of the underlying configuration for the containers that are going to run. So I think it's been pretty cool to have all those different extension points and different implementations from different people that have gone to build really cool things on top of Containerd.
Yeah, I think just to add to that, I mean, we understand the need of the Kubernetes ecosystem, right, with CNCF to be able to have things like CDI device support, right? So we were in the COD originally to put this CDI together and make sure it was enabled in Containerd and Cryo simultaneously, right? So we do make sure that any extension point that is needed in the ecosystem is available in both container runtimes or all three if you want to include Cryo Containerd. I'm Docker-D, sorry.
Yep, absolutely. So yeah, we've already jumped into this, so I don't know how much time we'll spend on this, but you know, Mike has mentioned multiple times about the CRI. So you know, the Containerd project, initially, if you were around, you know, 8 years ago, there was the Containerd repo, and then there was a CRI project that was a separate code base that was vendored into Containerd. So PRs, you know, as CRI APIs were implemented or bug fixes, you know, we had sort of a song and dance that we did to make Containerd releases with CRI. Fairly soon, within a year or so, we merged the CRI project into Containerd proper, initially as its own kind of sub-project, but now as part of the core Containerd code base. And so, as Mike said, similar to Creo and others, you know, as KEPs, you know, drive changes in CRI, then obviously all the runtime implementers need to wire that API to functionality. You know, maybe it's Containerd functionality that existed, maybe it requires changes, maybe it needs a new implementation. And so, you know, that's the sort of flywheel of the broader ecosystem of Kubernetes and the CRI plugging into Containerd. And I think we've talked some about that. So, we've mentioned a few sub-projects. It's a growing ecosystem that's exciting to us because, again, you know, hopefully that means that we've made good design choices. That means, you know, people can extend Containerd in useful ways without having to open a PR in Containerd and hope that we like it or review it or approve it. And so it's allowed for sort of the generation of additional features and capabilities beyond our own project. So, you know, I don't know if you want to talk about nerdctl as one of those extension points.
Yeah, I can.
Yeah.
Is this right? Yeah, so Containerd focuses on extensibility and support for cross-platform. So we have runwasi as the default runtime plugin. This is for Linux. And for Windows, we have runHCS plugin. And for FreeBSD jails, we have runj plugin. And we also support containers that doesn't use native platform. So we have a runwasi plugin for running WASM workloads. And there's also Kata containers plugin. This uses virtual machines for more strong isolation. And Google provides runSC plugin based on gvisor. This is implemented using ptrace sandbox or other functionalities, such as seccomp to strong another isolation. It's similar to Kata plugin, but this is attractive when you are running containers on instance or virtual machine, because running Kata inside existing virtual machine is quite difficult or sometimes slow. So in that case, gvisor plugin is attractive. And aside of runtime plugins, we also have snapshotter plugins. Yeah, so we have regular snapshotters such as overlay FS and B3 FS and ZFS and device mapper, just like Docker. And in addition, we have remote snapshotters, or we also call it lazy loading snapshotters. This supports putting image contents on demand to shorten the container startup time. So you don't need to wait for completion of print images. You can just run containers directly from registry. And there are a couple of conflicting format specifications, such as STD. This one is forward compatible with OCI v1, so you can just run STD with legacy Docker. But to enable lazy pulling, you have to use Containerd or other container engines with the support for lazy pulling. And there are also alternative image formats such as NIDAS and overlay BD. And I forgot to mention that in the slide, but there's also another format called Sochi. Sochi is also compatible with OCI.
If I can add here, so there's Sochi, which is that you were just talking about, that is, I think, from Phil's company, and then my company also has another one that is image streaming that is on GKE. So it's an interesting way that you can plug in remote snapshotters into this model, and there's a bunch of different implementations. They've got different trade-offs, different benefits, but we've got this interface for being able to do that. And some of these projects, like StarGZ and NIDAS and Overlay BD, are actually Containerd subprojects, versus others are governed differently or managed differently.
Yep. Yeah, so the beauty is our companies don't have to agree on how to lazy load images, but we can both participate in Containerd and make these extension points so we can, investigate these different paths to implement, features like image streaming, lazy loading. Cool. So keeping with that theme, Akihiro has created nerdctl. I'm sure many of you know what that is, but you want to say a few words about nerdctl?
Oh, yeah. You want to put this right? Yeah. So nerdctl stands for Containerd CTL. It's a subproject of Containerd, and it provides the same command line user interface as Docker, including Compose. And I originally made nerdctl for facilitating new experiments in the Containerd platform, such as lazy loading snapshotters, and also with the faster rootless containers with bypass for nettiness, which is my experimental project to accelerate rootless containers by injecting several syscalls. And nerdctl is also used for debugging Kubernetes nodes too, but you can run nerdctl without depending on Kubernetes. And the command line example is just shown as here. It's just same as Docker, just a nerdctl run or just nerdctl compose app.
Yep.
And I have other slides. Yeah, so this is a project under the CNC sandbox. It's Lima. It's something similar to Docker machine. So Lima creates a virtual machine and run containers inside there. It's similar to Docker machine, but Lima uses nerdctl as the default container engine. And you can use Lima just like this. And you can use nerdctl.lima command to run containers. And it supports automatic port forwarding. So you can just use localhost 80 as the port to the container. And there's also another project. It's Finch. It's AWS. It's a Containerd engine based on Lima and nerdctl. Maybe other guys want to add something about Finch.
Yeah. So, Lima, as Akihiro said, is a CNCF project. He donated it last year or a couple years ago. And, if you've heard of KoLima, KoLima is built around Lima. Right. Rancher Desktop is built around Lima. So, again, we've, at AWS created an open source project that bundles Lima, nerdctl, build kit and obviously built around Containerd for similar capabilities that we wanted to provide to our customers and to the open source community. So yeah, these foundational pieces have just been useful to lots of folks, and again, have built around this extension point, this idea that Containerd can be a core that you can build something around it, you can wrap it, you can extend it in various ways. So that's been a way to allow lots of people to do interesting things that they like to do with containers all around the Containerd ecosystem. And as I think Sam just said, they each, may have a slightly different set of maintainers or governance model. We're not enforcing that on the sub-projects, and some of them are outside of, Lima is its own standalone CNCF project. So yeah, there's more that we could say about that. There's a lot of other sub-projects we haven't even had time to chat about. Some of the runwasi folks are here. They've got a very active project that's underneath the Containerd umbrella that they maintain and extend Containerd for that community. So why did we move to 2.0? Watch Sam's YouTube talk, get all the answers in a few weeks. But essentially, as I said at the beginning, the project is effectively 8 years old. We've had a fairly steady release cycle of 1.0 within a year of launch, and then 1.0 through 1.7 over the last 6 years or so, about one minor 1.x release a year, and added LTS. We'll talk about that in a few minutes in the past year. But over time, like any software project, we've had a set of deprecations, things we've learned as we've gone along, and we've also made very, very clear guarantees about API stability, backwards compat, and so the only way to really move any of these deprecations to removals was to do a 2.0, and so you can debate about when that should be or how that should be, but for us, the past year and a half, we felt like it's time to go ahead and do that, to be able to move some of the new features into production readiness that we've had as experimental, move those deprecations to removals, and provide some of the scaffolding around that Sam talked about with warnings and helpers to help you know what you're using that's been deprecated. So yeah, that's really the net of it. No big aha moment that we had to do it now, but that's in the life of the project. It seemed like the right time to do that. Any other thoughts? 2.0?
Yeah, I can add stuff here. I'm not going to repeat all of the things that we covered in the earlier session, but like Phil was saying, it's kind of at the point in the project where we needed to take a look at all of the set of things that we had built and whether they were going to be sustainable for us to keep supporting them. So we did remove a number of things in 2.0, and that's why it's sort of a major version and has some breaking changes in it. But we were trying to remove things that we knew either were going to be not really recommended for people to use anymore, like Schema 1 images, or were going to be hard for us to continue to support in the long term, like our prior shim implementations. The original shim we had 3 shim implementations in Containerd prior to 2.0, and in 2.0 we went down to just a single one that's going to be sustainable for us to support in the long term. I think we've got a slide on this too. Phil was briefly mentioning LTS, but we were also looking at, how do we make this migration easy for people and make it as painless as possible. One of the ways is that 1.6 and 1.7 are not immediately going away. 1.6 in particular is going to stay around for a while as a long-term supported model. And 1.7 is also going to stay around with a degree of extended support. We're going to continue to patch security issues in it for quite a while. And 2.0 will eventually replace it, and we've built some migration tooling. Again, I went into this in a lot more detail in the earlier talk, but we have a capability in Containerd that will now tell you if you're using any of the things that are going away in 2.0, and you can actually figure out whether you're going to be impacted and migrate away from that. But the sort of other theme is like most of the things that are in there we don't expect them to be impactful for most users of Containerd. Like if you're using the default settings of Containerd, you're not affected by the shim migration. You're not affected by the AUFS deprecation. If you have built container images more recently than 10 years ago, you're probably not affected by the schema 1 removal. So a lot of the things in there are really sort of about removing technical debt. I think there's also a slide in there maybe about sort of the new things that we had.
Yep.
I'm not going to go through this list, but these are a bunch of the stuff that we were excited about as sort of like newer stuff in Containerd 2 or things that we've stabilized in Containerd 2.
Yeah, and I'll keep throwing this out there, but yeah, if you weren't at Sam's talk, there's a lot more detail on a lot of these. And one of the reasons we're doing this format today is it took us a good bit longer to do 2.0. And I think if you look at the talk in Paris, I think if you look at the talk in Chicago, we covered transfer service, we covered sandbox service. So we've been talking about these features. Many of them were added to 1.7 as experimental. And so in 2.0, they're now stable, as some of these said. As some of the bullets here say, some of them are also new that are only in 2.0. So lots of good detail on that in some former talks and in today's earlier talk. Did you want to talk more about NRI?
I think I covered that earlier. I think
Yeah.
we can, if people have questions, we can always come back to it. But I think that one and like the next slide, I think we can skip for now.
Yeah, the image verifier. So,
These are just sort of newer things in 2.0.
yep. And we're down to 9 minutes, so we may have to speed along. Yeah, so Containerd went 2.0 last week, and then within a couple days, nerdctl v2 came out as well.
Yeah, right. Yeah, so in nerdctl,
It's on. Yep.
yeah, the rootless networking is refactored to support detached NetNS mode, which enables a faster nerdctl pull and nerdctl push. Previously, pull and push was limited to typically less than 10 gigabps due to the overhead of the user mode TCP/IP, but it's now as fast as root 4. This is about accelerating pull and push. It's not about accelerating containers themselves. And containers can be accelerated too with bypass for NetNS. It's another my experimental project, and it's still experimental. And with the detached NetNS mode, we also added the proper support for --net equal host and also local host registries. In nerdctl version 1, we couldn't access local host registries because in the rootless mode, the local host has a different network namespace.
Yep.
Yeah, and in nerdctl we added support for running systemd in a container without ---- privileged. So it provides user experience, such as just like playing in old virtual machines. This is often considered to be anti-pattern when used Docker-style containers, but at least this is useful for testing multiple processes in a container because it's very similar to playing old virtual machines. And in this release, we also received massive refactoring testing and other contributions from so many people. So I want to express my appreciations to all the contributors.
Yeah, sometimes I think I should unsubscribe from nerdctl notifications on GitHub because his community is like so active. Like there's so many people involved in nerdctl, so that's been awesome to see in just a few years how many folks have gathered around to work on that project. Yeah, what does LTS mean? We talked about that a little. So, one of the things as we approached, knowing that we were going to do 2.0, we knew we wanted a release which we could label LTS so that we could give people the certainty that they could continue, that they could take time to handle any migration concerns, any deprecations that were going to impact them. I'm still absolutely amazed that people still have Schema 1 images in registries. I don't know what that means or what tool you're using, or you really are running images from over a decade ago, but that's impressive if so.
Docker Schema 1.
So yeah, LTS for us is a measure, of just our support to the community, that you can continue to use 1.6 for a good long while, as Sam said. But yeah, that's, we have a statement about what that means in the project repo. If you have questions about that, I'm sure we can answer them at the end. I'm going to skip over this for a minute, Mike. One of the things we were wondering if people would like to know about, KEP, that sort of path of activity that goes from a KEP to our project. We're missing a question. Or did I miss it? Did I skip it? Yeah, I did skip it. Look at that. So we, obviously every time we're at KubeCon, every time we give a project update, we'd love to invite people to participate in the project. And, you can always show your Slack channels and your repo and QR codes. We wanted to make it a little more personal. I think as much as I'm still excited to be a part of this project and open source in general, the color of my hair should tell you, I've been doing this a while, and I'm almost more excited when I see sort of new people come into our community who are younger, who have more energy than me, have more, usually smarter than me. And so, yeah, Kirtana is like an awesome person who just kind of showed up in our community. She's become a reviewer, part of the maintainer team at Containerd. And so I thought it'd be way more interesting for her to share, like, kind of how she got involved. I could blab on about my involvement, but I think it'd be better for someone younger and newer to the community to share your experience.
Hi, everyone. Like Phil mentioned, I'm one of the newer maintainers and contributors. Is this better?
Yeah,
Oh.
yeah.
So yeah, I'm one of the newer contributors to the Containerd and Kubernetes ecosystem. I've been around for probably like 2.5 years now. And when I started off, the entire ecosystem in the space was very new for me. So I thought I'll just probably take a few minutes to go over what my ramp-up process was like and how my experience has been so far. So one of the first things I did was go over the documentation, of course, on the Containerd GitHub repo, and also all of the Kubernetes documentation that was available online. And one of the things that really helped me is to listen to the whole bunch of KubeCon presentations that the Containerd maintainers and folks from different SIGs have given. So this really helped me get a high-level understanding and also get an insight into what the focus areas for the communities look like for the next 6 months or 1 year. And I think I also immediately started trying to attend all the bi-weekly and weekly sync meetings that these communities have. Try that. Yeah. So this really helps to introduce yourself to the community and also get kind of deep level insight into the work items and projects that they're working on, and also kind of try and understand if there's any way you can get kickstarted or start contributing and helping in any way. One other thing that really helped me is to just go ahead and scan all the GitHub issues that were open in the last 6 months or 1 year and see if there are like small tasks that you can pick up. So these can be like really trivial test or bug fixes and improvements that you can help with, and then kind of work your way up to bigger tasks. And just as an example, one such task that I was involved with for a little over a year now is the image pull per runtime class feature. So once this feature is available, it basically gives the user the ability to pull an image for a particular platform and also a runtime specific snapshotter, which can be used to unpack an image. So to support this feature, we had to make changes in cry, kubelet image pull, and the garbage collection code path, and also in the Containerd side. And since the changes are pretty extensive, we needed to work on a KEP. And if we have time, I think Mike will go over the whole KEP process and what it helps with and what it looks like. But once the KEP was accepted by the SIG node and the kubelet garbage collection work group, we submitted the cry changes, which were released as part of Kubernetes 1.28 release. And then we kind of opened up PRs for all the code changes that were needed on the Containerd side, which have gone through a few iterations to factor in all the improvements that were going on for Containerd 2.0. And hopefully we can have that released in the next release cycle. And one last thing I'd like to highlight that really helped me is to reach out to all the great maintainers out here. They're really helpful and always ready to help, and even hop on calls if you want to discuss issues with them. So if any one of you are new, wanting to start off with Containerd and need help, so please don't hesitate to reach out to any one of us. We'd be happy to help. And yeah, I think these were like good starting points for me.
Yeah, awesome. Amazingly, we have used up completely 35 minutes of your time. So I think we will not be talking about KEPs, but Mike, Kirtana would be happy to talk to you afterward. So yeah, we'd love for folks, if you're interested, come find us on CNCF Slack. People that take the initiative, hopefully, as Kirtana said, we try and be helpful. She did show a chink in our armor that she had to look through the issues to find first good issues. So if you're a person that can help us, like go through our issues and get some of those labeled, that'd probably be even better for new contributors. I'm sure many of you know keeping up with your project issues and PRs can get a bit overwhelming for the core maintainers. So love some more help. And yeah, thanks so much for coming and listening to us at this late hour on a Friday. Thank you all.
I want to add one final thing. Phil, you've got a QR code at the end of it.
Oh, yep.
This was a new format for us to try, so we'd love feedback on whether this session worked for you or you'd prefer something else different. So yeah, please take the QR code and give us feedback on this. And also, we're all just going to be around right after here too. So
Yeah, sure. If you want to talk about KEPs, come on up.
All right, thanks everyone.